Good morning, everyone. Good to see you. I'm happy to have all of you here. My name is Helga Waage, and I'm here to talk about the progress of AI, how we got to where we are today, and where we could possibly go from here. I'm the CTO and co-founder of a company called Mobilitus. We focus on event discovery for live events, such as concerts and theater plays and other things. I do have a master's degree in artificial intelligence. I was actually the first person in Iceland that finished an advanced degree in AI back in the early 90s. And I actually had a master's degree in machine learning. So at the time, I had misgivings about the practical applicability of a degree in AI. But as I get easily distracted by shiny things, I decided that I could take 2 years doing something innovative and weird, and then go back to doing business software when I got back to Iceland. However, I didn't even turn on my slides. How do I do this? I see it here. Okay. Hi. Like Björgvin, I like to have pictures of myself. Yeah. So, but actually, this education has turned out to be remarkably useful in the past 30 years or so. So, how did all this start? Let's go to the beginning. Let's talk about Alan Turing. So in 1937, he published a paper where he asked the question, can we have a universal machines that can solve any problem? So up to that point, we had machines that solved specific problems. But he said, oh, can you just have one machine that does all of it? And this was, of course, a very interesting question. Alan, however, got a little bit distracted for the next 10 years or so because of this thing called Second World War, or as we optimistically in Iceland say, the last World War. But when he got back to it, he said, if we have a universal machine, can we make it fool people into believing that that too is human? So the desire to, and now this word that I never can say, anthropomorphize the computer is as old as the computer itself. Since we had a computer, we've always thought, how human can it become? So these were actually very exciting times after the war. People believed that we were getting into new times, such as we do today. And in 1956, there was this guy called John McCarthy who wrote a proposal that he sent to DARPA. And I'm going to read the proposal for you. We propose that a 2-month, 10-man study of artificial intelligence be carried out during the summer of 1956 at Dartmouth College in Hanover, New Hampshire. The study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions, concepts, solve kinds of problems that are now only reserved for humans, and improve themselves. We think that a significant advantage can be made in one or more of those problems if a carefully selected group of scientists work on this together for the summer. This is a point in time where you had about 100 computers in the world, and they were still figuring out how to connect a keyboard to a computer. So he actually got funding, and this marks the start of AI. So let's break it down. He identifies 4 disciplines: natural language processing, how to make machines use language; machine learning, every aspect of learning; knowledge representation, form abstractions and concepts; and problem solving, which is kind of an umbrella term for everything else. So, who could refuse such a well-presented and well-defined and realistic project? So he got the money, and that marked the start of the first golden age of AI. So this is mostly during the 60s, so this is a time of significant technical optimism in the US. We are sending a man to the moon, and basically DARPA wrote open-ended checks for whatever they wanted to do. People pretty soon figured out that this was a very open-ended definition. So during the time, most of the progress were actually made in 2 of those fields. In natural language processing, people figured out that we needed to invent something called computational linguistics to actually define how to use, how to present the linguistics so that computers could understand them. We really needed to translate Russian to English, and then people started to play around with chatbots. The other interesting field that people were focusing on was knowledge representation. How can we take everything that we know and put it into such a format that a computer can use it to reason? A little bit of effort was spent into problem solving, but machine learning, we didn't really have the tools, we didn't have the technology to actually do this. So after about 20 years, the big success case of that age was ELIZA. ELIZA was a chatbot that simulated a psychiatrist. Basically, what it did was it took whatever you said, turned it around, and posted back towards you as a question. And again, it played on your tendency to give human characteristics to whatever you're talking to, and also on your desire to talk about yourself. So this was actually got a lot of attention, a lot of publicity, and the story goes that at one point in time, Weizenbaum, who was the inventor of this, his secretary sent him out of the office because she was having such a private conversation with ELIZA that he didn't want him to overhear. During the mid-70s or early 70s, DARPA got tired of pouring money into something that didn't really result in anything usable. Most of this was basically just basic research. So we entered the first AI winter. And the result was the hard problems are easy and the easy problems are hard. It's easy to do something, do a theorem prover for algebra, but to actually get the understanding of a 2-year-old is something that we did not crack at that time. So we had a few years of AI winter, and then we got into the second golden age of AI. Another boom times in the 80s. And in that case, we were still focusing on natural language processing and knowledge representation, which was, we had found a way to actually formalize knowledge, create all knowledge into axioms and put them together. So So to induce information from them. Another big process was search. AI-based search was something that was really successful during the time. And the end of this era, we had a very successful expert system that kind of looked like this. Very large if-then-else blocks where you were kind of moving between states based on questions. So you basically had huge systems asking you all kind of questions and trying to find a solution. The most successful of those applications, in my opinion, was the container port in Singapore, which was run using expert system. This is a transition port, so there's a lot of containers that are en route to somewhere else, and it was very important to try to get stuff fast from one point to another without moving too many containers. And this is also marks the moment that no longer is all AI research funded by DARPA, basically, or the governments, but private money is actually coming into it. The companies are starting to spend money in AI. But all was not well, because we had more people that, like Björgvin. So we had the second AI winter entered when there was a new kid in town. The internet showed up, and basically all the money went there. Very exciting times, not for AI research. However, a lot of things were still moving on. People are still working on problems in AI, but mostly in practical applications. So search was very active. Also, industry-specific solutions such as robotics and computer vision. And of course, people are still focusing on natural language processing, such as chatbots and translations and stuff like that. And that's what I was doing at the time. This is a chatbot we created at the company I was working for at the time, called Teresa. She was an authored chatbot. It meant that there was a content creator that actually wrote the dialogues or vignettes within the bot, but she wasn't as helpful as Eliza, so she kind of pushed you off if she didn't like you. Of course, yeah, I've had cats called both Eliza and Teresa. It is important. But the big success story of this time, early internet age, was of course Google, which was not the first search company. Björgvin, of course, had this great city web page at the time, but there were other search engines, but Google actually managed to solve this in a very smart way, and basically using AI technologies. So, what happens next? Data. In the early 2000s, we of course had all kinds of issues. We had the shock of 9/11. It turned out that the new girl in town didn't really deliver on the revenue stream, so the .com crash happened. But we had collected a lot of data, because as soon as we saw data, we started collecting it, and we thought, okay, how can we use data? So the new millennium, we had data, we had machine learning. Let's throw all the data at the neural nets and train them and see what happens. So basically, neural nets started to crawl into all other aspects. So if you remember, in the beginning, we didn't spend a lot of time on machine learning because we didn't have the technology. But now we had the technology, we had the processing power, and it turned out that something that was too difficult to solve in the early days was actually the foundation of many other technologies. So we had big process in natural language processing once we had neural networks. And we also had started to use neural nets in industry-specific applications. A curious thing also happened during this time. So a lot of AI applications decided, oh, we aren't really AI. We are robotics. It's not AI. So there was a lot of kind of moving away from AI for specific applications. And based on the failure of the expert systems, nobody was doing anything in knowledge representation. The process the progress in natural language processing based on the success of the network led to the first Icelandic language technology effort, which is the one that was before the one that Björgvin was talking about, where they spent a lot of money basically on computational linguistics for Icelandic, but also we did a text-to-speech system that was very successful and using the state of the art at the time and used by a lot of students and some news websites at the time. Another curious thing happened during this time, where you had a lot of data. You had not that many people that knew about this, but you wanted to do a lot of things. So a lot of companies started machine learning competitions. So instead of giving the money to a research institute, they opened up a competition and said, okay, you can have $1 million if you can, for example, for Netflix, if you can improve my recommendation algorithm by 10%. And here's the data sets, go wild. And this resulted in they launched this competition. 6 days later, they had the first system that was better than the one they already had. 6 months later, they had over 20,000 teams participating, and this created a huge community of teams collaborating, sharing data, sharing information, and new teams forming, and there was a lot of growth that was created because of this competition/cooperation that was going on at the time. 3 years later, Netflix paid out a $1 million prize. So this was actually something that sometimes 10% improvement is actually very, very valuable. These kind of competitions are still going on. So if you're interested, you still have 2 more weeks to participate in the competition of translating American Sign Language into text. So if you want. Now we are entering the modern area of machine learning. Neural nets are basically everywhere. They are basically the underpinning of almost all technologies that we are using today, especially large language models. We are still not doing a lot in knowledge representation, but basically AI is used everywhere. Your cat is using AI. But based on this situation where you have neural networks that are creating something that sounds plausible, but you're not underpinning the plausibility with actual knowledge, because we haven't spent anything on knowledge representation for 20 years now. We are facing issues with quality control. We have lots of data. We have no idea what's in there. We have huge models. We don't know how they work. There's a lot of bias in the data. This is an example from the early days of COVID, where you had, the picture on the left is a healthcare worker that was measuring temperatures where they're doing, you probably remember they were measuring the temperature of people in big crowds to pick out the sick ones. And this guy was doing that. And the model said, oh, this is somebody that is holding a gun. And with poor whitewashing, literally, they decided that this was no longer a gun. This was something else, not a thermometer, but still a more peaceful device. And we can't really solve those issues if we don't have a knowledge representation model underpinning the language models. There's no way to know how you got to 42 if you don't know what the question is. So am I saying that we will have another AI winter? I don't think we will have another AI winter. And the reason for that is because the innovation today is driven by industry. It's not driven by government funding. It's not driven by universities. We have multiple sources of funding, and basically a lot of companies, all the companies, are doing all kinds of private research, solving their specific problems, addressing their specific needs. And there's no way that all of that is going to fall down because of an overhype. I'll just say it, an overhype of a specific technology platform. So having said that, I do think that there's significant advantage to be made in one or more of those problems if we do work together for the summer. Thank you very much.